This video will show you how to configure the motherboard parameters. You can find the common parameter list in the manual. Preparation: ensure all wiring is connected and light burn is linked. First, let's check and adjust the movement direction. Click the arrows in the Move panel to test the axis directions. If motors don't move, check wiring. The board has built-in drivers. As seen here, the x-axis is inverted while the y-axis is normal. Method 1. Open the Edit menu in Lightburn and select Machine Settings. For version 2.0 or later, find Machine Settings under Laser Tools. Click the arrow next to Output Setup to expand the parameters. Click Yes in the pop-up dialog. Locate X direction pin, invert $3. Toggle true or false to flip the X direction. Since my X-axis is inverted, I will change the true or false value for this setting. Below is Y direction pin, invert $3. Mine is normal, so no change is needed. After adjusting, click Right to save the parameter changes. Once the success prompt appears, click OK to close the settings. Now, let's test the movement direction again. As you can see, the movement direction is now normal. The manual lists default $3 values refer to your actual test. Next, let's look at the second modification method. Open the console window in Lightburn. Type and press Enter to view all motherboard parameters. Find the 3=1 parameter, which controls the XY movement directions. This parameter has values 0, 1, 2, and 3, representing 4 movement scenarios. If directions are wrong, try 3=0 through 3 until you find the correct one. Here is a demonstration of the operation. First, let's change the $3 parameter to 0 and test. At 3=0, the x-axis is inverted and the y-axis is forward. Next, let's change the $3 parameter to 1 and test. At 3=1, both the x and y-axes are in the forward direction. Next, let's change the $3 parameter to 2 and test. At 3=2, both the x and y-axes are in the reverse direction. Next, let's change the $3 parameter to 3 and test. At 3=3, the x-axis is forward and the y-axis is inverted. Thus, 3=1 is correct for this machine. Values vary for others. I'll update $3 to the correct value. Now, let's run the test one more time. As you can see, the movement direction is normal. Note, whether you use machine settings or the console, the final result of the parameter modification is the same. However, there are differences in the interface and operation logic. We will demonstrate using the console. as machine settings does not display all available motherboard parameters. After correcting the movement direction, verify the machining accuracy. Create a square in Lightburn, for example, around 50 by 50 millimeters. Set to line mode. Use common test settings, approx. 50 millimeters per second speed and 15% power. Note, these values are not fixed. You can adjust them slightly based on your needs. Run the job and measure the actual dimensions to check for accuracy. For small and medium coat-to-laser engravers, default step rates are usually accurate. Adjust only if necessary. If the actual engraved dimensions differ from the set size, you need to adjust the motherboard parameters. Open the Lightburn console, type, and press Enter to list all motherboard parameters. Locate $100 X-axis step rate and $101 Y-axis step rate. Rule of thumb: the larger the step rate value, the larger the actual engraved size. After entering the command, press Enter to apply the changes. Then, type to verify that the parameters have been updated successfully. Please fine-tune and test the parameters based on your actual measurements. Once the initial test is accurate, it is recommended to test with squares of various sizes. This ensures comprehensive verification of the machine's precision across both short and long distances. Prerequisite: adjust homing direction only after verifying the motor movement direction. For this machine, the homing origin is at the top left. First, click Home and observe if the machine moves in the correct direction. However, it is moving towards the bottom right, indicating both X and Y homing directions are reversed. Warning: if the direction is wrong, power off immediately to stop movement and prevent a crash. Open Machine Settings and locate $23 homing direction invert. This parameter controls the direction of the homing movement. Since both axes are reversed, I will toggle the true or false status for both X and Y under $23. Click Right to save. Once successful, click OK to close the window. Test again. As you can see, the machine is now homing towards the correct origin. If the machine does not respond to home or fails to stop when hitting the limit switch, please check the limit switch wiring or verify if parameters $5 and $7 are set correctly. Next, we will demonstrate modifying the homing direction via the console. Send the command to query motherboard parameters. Locate parameter $23. Since we just corrected the direction, the current value shows 23 equals 3. Referring to the manual, values 0-3 for $23 correspond to different homing directions. Let's test the direction for each value. When 23 equals 0, it homes to the bottom right. When 23 equals 1, it homes to the bottom left. When 23 equals 2, it homes to the top right. When 23 equals 3, it homes to the top left. Therefore, for this machine, 23 equals 3 is the correct setting. Note, the correct $23 value varies by machine. Please adjust according to your actual setup. Please refer to the manual for the parameter values corresponding to your limit switch type No or NC. Query the motherboard parameters in the console and locate $5 and $7. Modify and test these parameters based on your specific switch type. If you are unsure of the switch type, try the trial and error method. Test all for combinations of parameters $5 and $7 until the homing function works correctly. If the pull-off distance after homing is insufficient and the limit switch fails to release, please locate parameter $27 in the console. For example, 27 equals 3. This parameter defines the homing pull-off distance in millimeters. Adjust this value as needed to ensure the limit switch is correctly released after homing. First, type in the console and press Enter to query all motherboard parameters. Locate parameter $60 in the list. Default value is 0.7. This controls the motor driver current. Recommended range 0.4A to 0.8A. Rule: heavier loads require higher current. Lighter loads allow for lower current. Generally, the default works well. Adjust only if necessary based on your setup. Next, locate parameters $8 and $59. $8 controls stepper idle lock, 0 equals disabled, 1 equals enabled. Note, you must power cycle the motherboard for $8 changes to take effect. $59 default 0.15 is the hold current when the motor is idle. Warning, do not set this to high, as it increases motherboard heating. Parameters $41 and $42 are laser static protection settings designed to prevent fires.
默认设置通常为$41等于20功率阈值和$42等于5时间阈值。
Logic: if the machine is stationary and laser power is 20%. The laser will automatically shut off after 5 seconds for safety. The range for $41 power is 0-100 representing percentage. Setting $42 to 0 completely disables this safety monitoring feature. Locate $110 X and $111 Y. These parameters define the machine's maximum rate. Default is 18,000 mm per minute. Adjust within 0.30000 mm min based on motor torque and load. Next are the acceleration parameters, $120 x-axis and $121 y-axis. Since the y-axis carries a heavier load, the gantry, its acceleration is usually set lower than the x-axis. Recommended scanning speed, approx. 18,000 mm per minute, 300 mm per second. Cutting or line speed, not recommended to exceed 3,000 mm per minute, 50 mm per second. If you notice jitter at the start or misalignment at endpoints during cutting, for example, at 30 mm per second, it indicates excessive inertia. Please lower the max rate and acceleration for both axes. $130 X and $131 Y define the maximum travel distance for each axis. Set these values based on the machine's actual physical working area. While they usually control soft limits, this feature is disabled by default, so normal operation is unaffected. However, during homing, these parameters determine the maximum search distance. Example, if the machine needs to travel 500 millimeters to home, but the parameter is set to 400 millimeters. The machine will stop after 400 millimeters, causing the homing cycle to fail. This covers the most frequently used core parameters. For other less common or advanced settings, please consult the parameter reference table in the user manual.